This video will demonstrate the process of using the 3D structure tool within SMS to generate a 3D representation of a bridge, as well as the mesh within the bridge footprint. For this demonstration, we're starting with a mesh, as you can see on the screen, that's already been developed for the existing condition, but it does not include details representing the bridge piers or the bridge deck. If we zoom in on the bridge location within the mesh and take a closer look, and rotate slightly in 3D, we can see that the roadway embankment on either side of the bridge opening is represented within the mesh terrain. You can also see that the spill-through abutments on either side of the bridge opening are represented, as well as the channel terrain and the overbank terrain. What we're going to do in this exercise is not only add a 3D structure to represent the bridge, but we'll also be updating the mesh to include holes to represent each pier location. But it does help to be in plan view. Hold the control key, click on the plan view tool, and then we can actually turn off the elements from our previous mesh. The first step to add a 3D structure is to right-click on map data and create a new coverage. Expand models at the bottom of the dialog. Expand the 3D structure and then select 3D structure. And we recommend keeping a 3D structure as the prefix for the coverage, although you don't have to, but it's also helpful to add another or additional identifiers to make this unique from when you have multiple structures. I'm just going to add this as 3D structure main bridge. And the next step then is to draw a center line to represent the center line of the bridge, and then also arcs that represent the pier locations. If you happen to have a CAD or a GIS shapefile that show the bridge location as well as the pier locations, that can be helpful. As an example, I do have a shapefile that I've opened into SMS, and you can see the bridge footprint as well as the piers. So using that as a reference, make sure I have the 3D structure selected and the Create Feature Arc tool. I'm going to draw a center line from left to right looking downstream, and I want to start at a location that's well within the embankment on the left, and then I want to make sure I extend into the embankment on the right, making sure I don't leave any gaps. Double click to end that. And then also, I want to select that arc, and I want to redistribute or add vertices to represent roughly the target spacing that we're interested in developing this mesh. Generally speaking, we recommend between 5 to 7 elements per span. So for this, I'm going to use just 24 segments. So you can see it's added those vertices. Then at each pier location, I'll add an arc to represent the location of the pier as well as the alignment of the pier. And then optionally, if we have skewed bridges, or if you have a bridge that's skewed to the flow, you can add additional arcs along either side, something like this on either side. And what that's going to do, if you add abutment arcs, is what we call these, it will align the elements through the bridge to those arcs. Okay? But it's only necessary when you get fairly highly skewed scenarios. For this case, it will be okay to have elements that are perpendicular to the bridge, so I'm just going to leave those arcs out. All right, so I can turn that off for reference. The next step then is to go ahead and edit or enter the 3D structure parameters by selecting the 3D structure coverage. Right click, we'll go to Edit Structure. It should pop up the dialog. At the top, we see structure type, choice is bridge or culvert. We'll stick with bridge. And we have 3 tabs on which to enter data. First one is the Profile tab. If we have a constant profile, you can leave this box checked and enter an elevation. But in this case, we've got a slight or moderate slope. So we're going to edit that. And SMS offers a simple way to enter this, where we can just enter 2 points to find the distance from 0 to 1 and the elevation. So on the left bank, it's 575.5. From my notes here, the right bank is 575. So it's a fairly mild slope. What it's going to do then is going to take this profile and stretch it across the length of the arc that I drew for the center line. Okay? So if that works for your scenario, this makes it a lot easier. But if you happen to have distance or station elevation pairs along the length of that arc, you can enter that as well. We'll do the same for the low chord. Deselect that box, click Edit. We're going to add a second point and just show the distance from 0 to 1. Elevation is 570. And then on the other bank, 570.5. Okay, that looks good. Now we go to the next tab, Bridge Properties. So real briefly, if your piers all have the same width and length and shape, then you do not need to use this option at the top. But if they are different, you can check this and it'll pull up a table where you can assign different properties to each individual pier. In this case, they're all the same, so we'll leave that deselected. Our bridge width is 35 feet. Our bridge ceiling roughness is 0.05. The pier type group would be for cylindrical piers, single or multiple. In this case, we have a wall pier, 6 feet wide, and it is 20 feet long. We have a sharp end type. And then these next two options we typically leave deselected unless you want to, for whatever reason, you want to modify the number of segments through the middle of the bridge or on the faces. You're welcome to play with that. We mentioned the option to add abutment arcs if you have to skew the elements through the bridge. So if you add abutment arcs, you need to check this box. And then the element width around the piers. In this case, we're going to use 3 feet, so roughly half the pier width. And the number of side elements, typically recommend between, say, 3 and 5 elements through the bridge. 3 ought to suffice in this case. And then for the wrapping width, we use 20 feet as an upstream wrap, is the same thing, and 20 feet on the downstream. If you have a case where you have two bridges that are close, say like an interstate bridge, a pair of bridges, you can deselect either the upstream or downstream if you need to turn one of those off in order to fit those bridges close enough to each other. Next, we select the elevation raster. If you don't have a raster, you can assign elevations to this mesh after it's created. And then we preview the bridge mesh. You want to take a close look, see if everything looks reasonable. You can see the 3 elements through the bridge opening, and we've got a wrapping layer on the upstream and downstream face. Otherwise, that looks pretty good. All right, the next step then is we're going to go ahead and create the 3D bridge, the schematic or the representation of the 3D bridge. And we have to add a tip elevation for graphic purposes. So I'm going to enter 540 there. And we do want it to create the mesh coverage as well as the 2D mesh. And before I click OK and tell it to create those things, looking ahead at the overtopping tab, if you do have overtopping of the deck, okay, not the approach embankments, but just of the deck, you would select this box, enter the appropriate weir length. It defaults to the length of the arc that you entered, and then also the type. But if you do not have overtopping of the deck, we recommend not selecting this because it does add additional calculations in the simulation. So we'll go back to the Bridge Properties tab. We're ready to create these 3 items. So go ahead and click OK. And then we can rotate the image to see what we've got. Now I'm going to go ahead and turn off the 3D structure coverage so we can zoom in and take a better look. All right, so also I'm going to turn on mesh elements so you can see the mesh that it created. All right, so we've got the 3D structure. You can turn that off and on as well to see the holes in the mesh where the piers are located. And then notice that it created this 3D structure bridge footprint grid. All right, so that's the mesh that we're going to insert into the overall mesh. But if you look at that, then that mesh coincides with this footprint that it created. We're going to take this footprint, insert it into our mesh generator coverage, and then tell SMS to insert this mesh within this polygon when it creates the overall mesh. All right, so that's what we're going to do right now. So let's go ahead and make sure I'm in plan view. And I'm going to go to my mesh development folder. I've got a mesh generator coverage I created previously. Let me quick turn this other coverage off. Before I edit anything, I'm going to go ahead and duplicate this coverage so I can keep that. I'm going to turn that off now. And I'm going to rename this new coverage. Mesh Gen, let's say, with bridge. Okay. And what I typically recommend is, knowing that we're going to have to insert a polygon that is very similar to this one, and in your case it may not be, I still recommend you follow this procedure. basically delete any arcs that might be in the way or within that footprint. And so I'm just holding the Shift key. I'm going to delete any of these arcs. All right, so that'll affect the polygons all around. And then any nodes that are going to be in contact with this new polygon, I'm going to show you a best practice that I've kind of come across. So that's the polygon. I don't want him to even be close. So what I like to do here, this is maybe just a personal preference, but I like to move these out of the way, and I'll show you why I'm doing this. Again, I'm just considering this a best practice. It works easier than the cleaning tool that some might use, I think. So they're out of the way. Now I'm going to go to that coverage, the footprint that it created. Go to that coverage and select all of those arcs. Right-click, select Copy to Coverage, and we're going to copy that to that new Mesh Generator coverage with bridge. Click off to the side to deselect that. You can turn that off. Now, click on the Mesh Generator coverage with bridge to make it active. And now this is what I found this to be just a best practice, is that now that we grab each one of these nodes and reconnect them, as you grab this node and drop it, you'll see the frame forms, and that's snapping it, and it's automatically merging that. And again, I've just found this works better. Sometimes the clean tool modifies or moves things, and it's pretty critical that we leave this footprint alone so the mesh can be inserted easily. So I'm just connecting. We can connect these arcs to intermediate points. That's just fine. And we do that on both sides. Okay. And now, in your case, it might take some more editing to redistribute vertices, to clean things up. This is just a quick example. But now that we've edited all these arcs, we have to rebuild polygons. And now we have to reassign type of mesh. But first of all, let me click on the bridge mesh polygon and go to those attributes. This is something different or unique. It's not a mesh type that we're actually going to set, although it's under mesh type. We're going to tell it that that polygon will be replaced with the 2D mesh or U-grid we've already created. And then we have to select what that is. And so that's the 3D structure, main bridge, footprint grid. All right, so instead of creating a new mesh, it's not going to insert that mesh here. Click OK. And now for these surrounding polygons that I had set as patch previously, I can hold the Shift key and select all of those. Right-click and set those attributes back to patch. Okay, and then also, looks like my other polygons all around here were impacted, and those were set at a constant paving density with a target size of 200 feet. Okay. And if I zoom out, now one last thing I recommend always doing is to go ahead with the polygon select tool, select it, hit Control A to select all the polygons. Right click, go to the attributes, and make sure they all have the elevation source set. And click OK, and we're good to go. All right, now the last step then is to use the new toolbox and select under the 2D mesh. If this is collapsed, open the 2D mesh, select the 2D mesh from coverage, and run that tool. Select your mesh coverage. We have to find Mesh Gen with bridge. I recommend using the merge triangles option with the default angle of 65 degrees. And the name of the mesh, we can call it Mesh with Bridge. Can't spell. Okay. Click OK. Might take 20 or 30 seconds. It says successfully ran. Click OK. Can close this. We'll turn off my mesh generator. Again, you can see the mesh that it created. And we can zoom in. Okay, so you can see how it's created the holes for the piers. And then we can also turn on that 3D structure under the U-grid folder. And then again, we can rotate the mesh and see how good a job it did. There you have it, a 3D structure and a mesh modified for bridge piers. That concludes the first part of this demonstration, and you'll follow similar steps in part 1 of the exercise.